Hey guys, you are almost on chapter 2, and this is the last video I got to make for Integrated 1. So we'll actually get to see each other again for our next lessons. Happy Friday. Hope your day is going well. Let's take a look here at what we got going on. So simplifying and recording work. Doesn't add anything new right yet. We will see one last type of mat today. But for right now, you are going to talk about how we can write our work. And this is where, if we had the old traditional ways of Algebra 1, Geometry, Algebra 2, I'd start plugging this thing called a two-column proof. Looks exceptionally like this down here, where you see left expression, right expression, explanation. We are actually going to get to see these, though, this year. So this is kind of preview for what will come later. It's probably a little tedious to you because a lot of kids like to skip steps, and in proving something, you have to show each step logically. Yeah, you can't just go from the beginning to the end, and I think that's hard for folks. It's a big struggle, I think, that people have in geometry. Remember, Integrated 1 is 1/3 Algebra 1, 1/3 Algebra 2, 1/3 Geometry. So you will see some two-column proofs coming up way later in this year. Okay? So you'll have plenty of time to get used to this. Not every single thing works this way, but today we're going to get practice with showing a step-by-step fashion. And they show a step-by-step fashion here. Here you have some student named Athena. She's doing some work. And she says, hey, I've got a left expression and a right expression. These are my original expressions. And then the idea is that you want to look and see, well, what did Athena do? What happened from here to here? What changed? So I see that 3x came down, the plus 4 came down, the negative x came down, the opposite of negative 2 came down, but my x squared went away. Okay. X squared didn't come down. Here I see, oh, hey, look, there's an x squared. So Athena removed the tiles that were the same from both sides. Okay? And it kind of continues on down. You notice, oh, what changes next? Oh, opposite of negative 2 seems to disappear. The opposite of the quantity 4 plus 2x went away, and we distributed at this point, and so on and so forth, until you end up with the actual answer. This probably seems really cumbersome to you. It is for this problem, I admit. The reason that you want to practice it here is it's a lot easier to practice this methodical skill of looking at a step-by-step process now, rather than wait until we start doing two-column proofs and I'm asking you to be very methodical in your reasoning, and you're like, whoa, I've never done anything like this. So think of this as an opportunity to practice more so than anything else. And you got two sets of these expression comparison mats that you can use to practice with. So that's really cool, I think. Actually got two more here as well. So problem 266, A through D, is really what I want you to focus on for the first part of things. Notice again, math notes. I hope you're keeping up with that. Do not put that off. Remember, it's going to be due in December for us. So you need to be keeping up with making some notes on these math notes. And we're talking about the associative and identity properties in this one. Okay? Let's flip on over to 218. Here we go. Using tiles to solve for x. So after all this work, we're finally going to get to the last type of mat that I'm going to show you this year. And pretty much the end of algebra tiles. Okay? So which is greater? They just start off with, this is a review problem for the most part. But what if both sides are equal? Okay. If the number 5 is compared to the number 7, it's clear that 7 is greater. However, what if you compare x with 7? If you notice, we've been extremely careful going through up to this question to not have a variable on one side and a bunch of number or constants on the other side. Okay? It's been very careful. If ever there was a y on one side, there'd be a y on the other side, you'd pull them both off. I'm not sure if you've caught that, but that's been very, very intentional because they've been building up to this idea. And it's interesting. You know, if we were to look at this, let's say here's y and here's some 1s. Hey, look, it's the exact same algebra tiles. Ha! I literally did this back to back to back. All right, so here we have y on this side and 3 on this side. And if y was 5, then I would say the right side's greater. If y was -2, I'd say the left side was greater. And if y was 3, I would say that they were equal. Okay? Remember, y can take on all kinds of values. And that's why we're going to be moving today to our last type of mat. And that last mat is going to look like this. So here you have two mats like you've been dealing with. You have the positive and negative regions. Now we have this like double bar between them. And that double bar is really an equal sign. Okay? This stuff is going to equal this stuff. So let's say I had something like y plus 3 minus the quantity. Oh, let's go with minus quantity 3 is equal to 1, 2, 3, 4. Let's say I have something like this. First thing I would do if I were dealing with this problem is I would flip up. I really like to distribute early on. My next step, I would make 0 pairs. So there's a negative and a positive at 1, a negative and a positive 1. I'm left with y minus 1 equals stuff. Okay? Now there's a few ways you could talk about doing this. One way would be if you made zeros. Okay? So if I added a positive 1 here and added a positive 1 here, I didn't change the equation because I've added the same quantity to both sides. Okay? That's really interesting. What this is sometimes called as this is making zeros. Because now, by adding 1 to both sides, I haven't changed the equation, but I've found a new 0 pair. Here's a 1 and a negative 1, and I can now see that y is equal to 5. Okay? Another way to have handled that situation, if I was back here, you could flip across this equal sign, but you're going to flip the sign. So instead of a negative 1, it's going to become a positive 1 over here. Okay? Both of those are valid. The first way looks more like what we teach you in algebra, so it's probably a little bit better. The second way is a little bit faster with the algebra tiles, so you're not pulling out all these tiles to make 0 pairs and all this kind of stuff and kind of complicating the mix, I think. I find it much easier to shortcut this and just flip across this. You can, of course, remove tiles from both sides, same as before. So that's also valid. That's pretty much it. That's the new mat. You're going to practice with the new mat for a few different expressions here, and then you're done. Okay? So let's look back through at what your classwork is for the day. 217. You're going to go through and you're going to record your work with Athena. You're going to go through this example. Then you're going to record your work on 266 for problems A through D. And then finally, you're going to, we've dealt with 273. We've kind of dealt with that, so I want you to skip down to 274. I want you to, actually, I did 274 with us, basically. So why don't you go ahead and do 275 and go A through F on that, okay? Go ahead and do those. You have a great weekend, and I'll see you on Monday. So we're finally to the end, even though I'm now going to go back and record all the Math 8 videos, and then I got to go record science videos. So I'm not done. You'll probably hear me making some comments that seem a little odd. I don't know. I'll try to keep it. Maybe I should have gone linearly through the days instead of just going all integrated 1 and then all Math 8 and then all science. But hopefully my videos all made sense and there's no silliness in them. Hope you had a great week. Hope this really worked for you. I don't know anyone who's ever really tried this before. We have the technology. Why not try it? You know. So hopefully we're able to make this week more meaningful for you than if we had just done a bunch of handouts. That's really the hope. So please have a great weekend, and I'll see you all on Monday.